Like that. Oh, yeah, yeah.
You could.
They're a lot more like you. Show the data. Yeah, it's.
Okay. So yeah, I hope you had some good share time there. We're about to start our penultimate unit. Wow, exciting, huh? Yeah, this is about conic sections. Conic sections are about, what does conic section mean? Do you know? Yeah, it's talking about a cone, and you studied cones before, haven't you? Yeah. In geometry, so you know what a basic cone is, but mathematically speaking, what we're looking at is something that looks like this, or this is a full cone extending in two different directions. And the orientation could be either vertical or be horizontal, as you could imagine. Going through the points there is a axis. So, and when we talk about conic sections, that means we're cutting this with the plane and seeing what shape emerges. Like when you cut this, kind of perpendicular to this axis here, the shape that results would be a, you see that would be a circle. Like if you were to cut it here and then look at it, it would be a circle, wouldn't it? So there are different ways to cut this, and all of them are called conic sections. And I want to talk about how else you can cut this and what kind of shapes emerge when you cut a cone like this with a plane, just like a slice through it. Go ahead and discuss with your neighbor, like what's like. If you want to staple your package, do it. So I can put some weight in. Okay, so maybe you got the shapes, maybe you didn't, but these are on the first page of the packet. I think it's the first page. Is that where they are? Oh. Do these make sense? Did you find some of these? Did you imagine these kind of shapes? Right, we talked about the circles, right? Perpendicular to that axis. If you tilt that a little bit, it's no longer a circle. It's a shape called an ellipse. It's like a circle. It's not an oval. It's a very specific mathematical shape. Parabola. Have you already seen that when you were envisioning cutting this? No. Parabola is formed when you only cut one of the shapes at a diagonal, or one of the sides at a diagonal. And that last one, have you heard of those before? Hyperbolas. Hyperbola is a graph. It has two branches, and we'll be studying those in depth through this unit. So this cone, just some other things, like the sides are called generators. And does it make sense that this generators dictate the size of the cone? Like it could be wider, it could be narrower. That point in the middle is called a vertex. And there are degenerate shapes, which is if the plane cuts through the vertex, that would be called a degenerate circle, which is actually a, what would that be called if it's that plane is cutting through that vertex? It's just a point, wouldn't it? It's a degenerate circle is called a point. It's a circle radius 0. And if like you can see how the hyperbola is made, if that were this were cut through that point, do you see what shape that would make? Think about that. If this plane went through that point through the vertex, discuss what kind of shape would that make?
Yeah.
How would you describe that shape? Yeah, it's a letter, isn't it? It's an X. Does that make sense? It would be an X. Right, those curves that were like this kind of come together and become. You can see it here. Here's the X. If you were to cut it directly like this. So if you were to come out a little bit, perhaps you could imagine it would have that nice curve above and below. But a degenerate hyperbola would be an X, which is nothing we studied directly, but I just want to let you know that those cases do exist, even though the cases are rare. So we just finished 10.1. Yay! We're doing 10.1 and 10.2 today, as you see here. And there is a little bit of a problem with this calendar.
Yes.
TBA, what does TBA mean?
Announced.
Be announced, okay. There's another problem. Next time is the day before break. I think it's a good idea to learn something new the day before break. It seems like a bad idea, right? So what's happening is that this whole section, we're gonna shift this down, and next time it's gonna be TBA. We're gonna do something that you're not accountable for necessarily at the end of break. So there won't be any homework and nothing that you're gonna be tested on. There'll be enrichment or an extension or something that you're not directly accountable for. So I hope that makes sense. There will be one quiz, probably right after we study hyperbolas. I don't know what that is yet. There will be one test at the end of the unit. And again, that's gonna be late April sometime, and I'll let you know well before that the exact date. So ready for 10.2? Sometimes I sneeze when I'm ready for 10.2 too. Bless you. Before we do 10.2, we're gonna do a kind of a warm-up. There are some blank sheets at the end of the packing if you'd like to use them. Do you remember the word equidistant?
Yes. Yeah.
So I'm looking for the set of all points equidistant from a single point. Now think about it. I'm looking for the set of all points that are equidistant from that point. Please discuss with your neighbor what the resulting shape would be. It sounds like you come to a conclusion. The answer is circle. Unfortunately, that answer, although it's correct, is not quite complete. A better answer would be sphere, wouldn't it? Think about that. The set of all points equidistant from a given point would be a sphere. Now, if the answer would be a circle, I'd have to change the question, wouldn't I? In a two-dimensional plane, set of all points in a two-dimensional plane, they're equidistant with a single point. I'm going to adjust this a little bit. I'm going to give you 2 points. I'll put one here and one here. I want you to imagine all the points that are equidistant from these 2 points, and don't call out the answer, and decide or discuss with your neighbor what shape would they make. Set of all points equidistant from these 2 points. Go ahead and discuss quietly.
From both. Yeah. Also. I don't think.
Yeah, I mean,
one. Yeah. Here.
yeah.
Did you get it? Can you show me? Show me with respect to those.
Yeah.
I'm saying. What can we, how can we describe this? A line? Well, a line if it's two dimensions here. So just to plot this out, I think this is the most obvious point, isn't it? The midpoint is the most obvious, but there are others. If I'm gonna stay in the two dimensions, like this is equidistant, isn't it? Or apparently in this. All those points form. What kind of line? What's the special line?
Straight angle.
Perpendicular. On two words, perpendicular. You guys are so cute. Perpendicular. It's like you didn't have geometry at all.
Straight angle.
Oh, right.
Oh, wait. Like a set.
Okay, we have a segment here. This line is the
Bisector.
perpendicular bisector of that segment. Yes, does that sound familiar? You remember like a whole chapter on, or a couple of theorems about this? If a point lies on a perpendicular bisector of a segment, then that point is equidistant from the endpoints of the segment, and the converse of that is also true. Good memories. Of course, that's in two dimensions. If we're going to three dimensions, the shape would be a plane. Could you imagine the plane? Like you can just imagine some more points that are equidistant from these two. They're coming out here, like right here, or here, right? Possible. No, this is too close to that. Here. Still beyond the plane that goes through that perpendicular bisector. Okay. Let's take it up a notch, shall we? This time we're not going to start with 2 points. We're going to start with 2 lines. The set of all points are equidistant from these 2 lines. Do such points exist?
Yes.
Where are they? Parallel line, right where? Right in the middle. I'm not, that's right in the middle. Parallel to the other ones. Okay, I'm gonna mix it up one more time. But before I do, I need to make sure you know, if I want to measure the distance from this line to this point, would you please discuss with your neighbor the best way to measure the distance from that point to this line? Because very often I hear just go straight down. Are we good with that being the distance to that line?
Atrocious.
But that's terrible. We have to measure the segment that is perpendicular to this line, right? So that would be the distance. And of course, that would have to be perpendicular. And please imagine that those are fairly straight rather than squiggly. So, okay, last question. I'm gonna keep that point and that line. I'm looking for all points that are equidistant from the point, and Chaz, you want to listen to this. I'm looking for you to find where all points, we'll keep it in this plane, all points are equidistant from the point and the line. Think about it, discuss, maybe sketch a few, see where you could, where are these points? And don't call it any answers, please.
I have no idea. If it's it'd be equidistant from the line.
Just draw a few of them. So equidistant from the point and the line.
It's the line that's a whole.
Parabola.
It would be, well, I think.
A parabola. Yeah. So maybe I guess.
Because I purchased good, not.
Yeah.
Are you finding some points?
Multiple points.
Multiple points. Interesting. Like how many multiples? What's that? Infinitely many. Says one of them right here. Is that one of the points approximately? Another point is maybe right there. This one right here, would that make sense?
Concur with Hudson's no.
No, that's terrible, isn't it? That's way too close to the line. So I'm gonna back that up away from the line. So maybe like right there, would that be more good? Something like that. Close enough. I appreciate that. So, and maybe like this. And eventually we just make a circle like that. Would that do it? Definitely not. Okay, and I heard the word floating around. What's the guess at the shape? Does seem like a parabola, doesn't it? That is what it is. It is what it is. So that is our first conic section we're going to be talking about today, parabolas. So let's go back to the packet. And well, the earlier part of the packet, 10.2. And I know up until this point, you studied parabolas before, but did you ever talk about the definition of a parabola? I know you talked about definition of a circle. All points equidistant from a single point. That's why a compass works. But definition of a parabola, and I hope this makes sense, is the collection of all points in the plane that are equal from a fixed point F called the focus and a fixed line D called the directrix. Have you heard those words before? Focus for sure. You heard focus, maybe not in the context of math, but directrix. Okay, so that's that line and the point from which the points are equidistant. So if we look here at a specific example, you can see that 3, 0 is the focus. Is that actually a point on the parabola, the focus? No, we could say that the focus is always in the parabola. Does that make sense? Always in the parabola, but it's not on the parabola. And notice how far it is from the vertex. Same as the distance from the vertex to the directrix. Any questions? Okay, I do want to point out a new vocabulary expression here. Latus rectum. Interesting phrase coming from the language. Latin. Spanish. No, I'm just kidding. Latin. Anyone here take Latin and would like to share some insight of maybe what these words mean?
I don't take it. Shazi knows too much. Yeah. I'm assuming it's like the bottom.
Okay, yeah, it's something like that. Lattice.
Not your knowledge of bottom.
Lattice meaning. It has to do with lateral.
Oh, it does.
Side.
Side. You were there.
Rectum meaning. All right, let's straight. I just know that because I looked it up on the last class. So straight side. So, and I'll look into that. We'll look into that a little bit more in a little bit. But let's talk about the equation. So we do some algebra. Yes, let's do it. So I'm going to have you maybe go back to your, no, don't go back to your room. I forgot. There's actually a place to do some work here. Example 1, this is some space for the derivation of the parabola equation in case your teacher wants to show you. I want to show you. I'm going to start with an axis. I know I sneeze when I'm excited about deriving an equation too. So bless you. Yeah. So I'm going to call this point here the, bless you. Really excited, I see. This is the focus, 0, A, and this is going to be the directrix. And I'm doing this to set myself up. This line here is y equals negative A. I'm doing this to set myself up so that the vertex of the parabola is at the origin. Does that make sense? Based on the definition of parabolas?
Yep.
Okay. From here, I'm going to have you just put your pencils down for a minute. After you've copied this down, put your pencils down. I just want to show you the mathematical derivation. You'll have some time to put this together in just a moment. I'm gonna talk about this point right here. Does it look like the point I've drawn is like equidistant from the point and the line close enough? It's not obviously close to either. It's probably not exact, human, allegedly. So according to the definition, this and this are the same. So I'm going to start my math here by saying that D1 is equal to D2. And again, keep your pencils down. I know that you want to write it down. Wait a minute. And I need to put some variables on this point. So I'm going to call this X comma Y because X and Y are both moving as opposed to the focus, which just stays there. But any point on the parabola could be represented by X comma Y. This point down here, I'm going to represent by the coordinates. Any idea?
It's like the common negative X.
It's definitely something common negative A, and it shares the X coordinate from the pair above, doesn't it? So I'm going to call that X as well. Not going to call like X1 and X2. That's the same X. I'm going to keep those there. Okay, what am I doing next?
Writing.
Well, I'm saying the distances are equal, so I'm going to use the distance formula. So again, keep your pencils down for now. Distance 1, I hope it makes sense that this is the square root of X. I'm going from here to here. So X minus 0 or X squared plus Y minus A squared. Yes. Equals, what is the length of D2? Will you check with your neighbor? What's the length of D2 algebraically? I'm not going to repeat this. I want to use what we have here.
This would be Y plus A.
Does that make sense? It's Y plus A. We could either look at the coordinates and say it's Y minus the negative A. Think about the expression. Or you can say this here is Y, this here is the length of A, so Y plus A. That's the full length of that. So equals Y plus A. Now what I want you to do is go ahead and pick up your pencils, catch up to this, and simplify it so that X's are on the left, Y's are on the right. No fractions, please. Check with your neighbor if you're stuck, of course, or when you're done, see if you got the same thing. Hopefully you did. Did you get it? Did it simplify nicely? It should be pretty at the end. X is again on the left, Y is on the right. You don't need to like square root or anything like that. Okay, who could talk me through the steps to simplify this? Yeah, Kieran. Okay, imagine that leaves you with this. I'm going to expand this to AY plus A squared equals Y squared plus
Squared plus 2AY plus A squared.
Might put a little separation here. Okay,
And then I moved the y squared minus the two ay plus a squared to the right side
okay. And what happened with the y squared? Then?
with two y squareds.
Really?
Or no, you subtract them, so there's no y squared.
Yeah, they just leave. Anything else cancel out?
And a squared.
Yeah, a squared also cancels out.
And then the two ay stays, four ay.
So that leaves us with x squared on the left and 4ay on the right. Are we good with this? Cool. Thank you very much. So this, hopefully this jives, this vibes, this y equals x squared. Right, nothing's changed. It's just we're in this book introduces the quadratic term first. So when you go up here, I want you to look at this theorem that it has about the equation of the parabola. Although it looks intimidating, I hope it makes sense. This is exactly what we were just talking about. It's just it has a horizontal shift and a vertical shift. Notice this x minus h like we're used to, and y minus k when it's directly happening to the variable. It's the opposite of what you see. So k is the switch. It's not the minus k. It's the vertical transformation. So I want you to keep in your brain a home base of, we know that y equals x squared is this parabola, right? You need to keep that. When you have that x squared, we know it's going to be a vertical parabola. As it says here, there are also not only vertical parabolas, but horizontal parabolas, in which case it's not x squared, but
Y squared.
Y squared. So notice it's the same form as the other one. It's just the quadratic term is different. Notice this h here is talking about the horizontal, and the k is the vertical, just like with the other one. Any questions? Okay, before we go on to specific examples, I'm gonna go back here. Oh, I didn't draw on the parabola. Let's draw this because we have this point right here. Do this in red. Okay, do you see the lattice rectum here? Oh. Do you see the lattice rectum? I'm going to draw it in brilliant turquoise. Here. And here. I'd like you to discuss in this situation, what is the length of each of those blue segments that I drew? Could you discuss with your neighbor, what is the length of that? Right, so this horizontal portion, this vertical portion, they should be the same, shouldn't they? Considering it's a parabola, and we know that each point is equidistant. What's the length of each one of those? Please discuss.
Nathan actually figured that on stuff.
I just with the 2A like
Oh,
yeah.
Do you see it? You see that's nice and clean? The length is what? 2A, are we good with that? All right, 2A over here. So if this part is 2A, then the whole lattice rectum would be 4A, wouldn't it? And when we look at our equation here, we see that 4A is part of it. So that coefficient of the y. And here, from here, I'm not going to say that 4A is the length of the lattice rectum. I think I said it in my last class, and I have to take that back. I'll call it LR because I'm running out of space there. That's inappropriate to say because A could be negative. So I have to adjust this by saying that the length of, the absolute value of 4a is the length of the lattice rectum. So what does a negative a do? What do you think it's going to do to a parabola that's opening upwards?
It's like
When
that.
it's downwards, if it's horizontal, go from the positive a would be opening this direction, but negative would be the other direction. So the negativity tells which way you're opening. Hope it also makes sense with the focus, right? If this were the focus, that would be negative a. So it should all work together. But let's do some problems. Okay. Resume share. Why is this not sharing? One moment, please. Okay, we are back. This is what I was just working on. Hopefully the screen wasn't frozen. People at home. Let's do one at a time. It's asking you to find the equation of the parabola described below. Let's see what you could do. Just the information you have so far. Oops, I didn't unfreeze that for A. Discuss quietly with your neighbor while you're doing this. Did you get it? You have all the pieces. Let's see if we can put them together. Yeah. Actually, this is the
How do you know?
it's like having a coefficient. Okay. So I'm gonna want someone to help us make the equation and then help us draw a really nice, accurate graph. Meaning, I want 3 points on the grid, 3 specific points. Who'd like to help out? Anyone? Yes, Miles.
So you draw your focus at 0,
Okay.
after vertex at 2. And because you know that the focus is at 0, 2, then you know that your direction is at the line is at white.
Extra. I like it. Okay.
So then, because you know that, you also know that your line across would be 4A, so it would be units, and
Oh, do we know A though?
A is 2.
Are we good with that? A is 2. That is key. And you got that from looking at it. Do we see that A is 2?
And then because it's 4A, your I guess your LR is 8 units across. And so because it has to be like symmetrical, I guess because parabola, it's 4 going out on each side from your focus. And then those are your 2 points, or your other 2 points with parabola.
Nice. We have the parabola. This is what it looks like. And can you give us the equation of the parabola, please? We'll start off with x squared equals 4ay. You told us that a is 2, so we know that x squared is equal to 8y. Are we okay with this? Yeah, that's perfect. That's exactly fine. Thank you so much. Any questions? Would you be more comfortable saying y equals 1/8 x squared. That's fine too, if you want to do that. But this book and the homework you're gonna be doing uses a quadratic first and then has the other stuff, so it's up to you. Miles, that was fantastic. Did you do the second one already, folks? Check with your neighbor, make sure that everything's good there. I'll call on one person to help us out with it. You get it? Could you take out your pocket parabola, please, and show me what this looks like? We know it's like this because.
Negative. A is negative.
And we don't have any letters or anything, you know, it's like this. Focus is always inside the parabola. If they didn't tell us the directrix, we'd have no idea. Okay, so I need some help from Nola. We able to do this one?
Think so, like, we only have 3 points.
Right.
Okay, so I got like the vertexes being 0.
Okay.
And, since the lattice rectum is 4A, would be
Last one was 4A, so it's 4. Okay, so
go out 2 points from each side. Yeah, that.
that and that. I'm gonna say absolute value 4A, as we're talking about lengths there. Okay, so that's equal to 4. Okay, so it seems like you got A.
What?
Do you know what A is?
A is
So we know that A is -1, and from there you were able to get the equation.
x squared equals -4y.
Any questions? Thank you. I like the symmetry of the two people who just did these two problems. That's nice. And I'm going to draw this, of course. And I would have to adjust these a little bit for the math purist to say that the focus, should it be a solid point? Is the focus on the parabola? It's not on the parabola, so a purist might change this to be an open circle, just indicates that it's not actually on the parabola, just like the directrix is dashed because it's not part of the parabola, it's just like where it came from. So I'm going to change it to that. I would never grade off for making it a closed circle there, but just to be considered. Let's do A. Check with your neighbor what the coordinates of the vertex are. Please show me the coordinates of the vertex. Show me the coordinates with your 2 hands. From your point of view, it is -4, -2. It comes from y minus, x minus. Okay, I'll let you finish that one. And you can continue working or you can zone out. I'm going to continue instruction at 12:31.
No, it's 16. I didn't see that.
There's absolute values. I suppose you know.
Because.
Or negative 4. Zero.
How?
Negative 1.
How?
No, it's just an A is in between.
No,
Yeah.
It's. This is A is 4, is 4A. Oh, again. 4A.
Equation 4A. So that is 600.
If you haven't discussed with your neighbor, please make sure you have. I'm gonna be talking about this at 12:31. We're calling on one lucky student to help us out. Make sure that your drawing includes as many points on the grid as possible.
But also 0, 4, 16. Yeah, but it's 4 times A, it's 16, 4 times 4. You're right. You just said A is 2, bro. A is 4. Yeah. So that means it's 4. No, focus is 0 constant. Focus is 0 comment 2.
what?
Why is it 0 not negative? No, it's still negative 4 to 2. 1, 2. The focus always has to be the same. I said A equals 4, so it's 1, 2, 3, 4. Because the point is at the origin.
Wait,
It must be. They have work with the direction. Fix, you know, is that. Yeah. No, I'm saying no, like. Oh, say, or is that what we meant? Because then you move it.
Hey, can someone? Keeping the.
Okay, folks,
Yeah, I know.
Yeah. How did?
I give you 15 seconds before I call on one person, one lucky student.
It's double.
No, actually, I was having it. Literally just off. Not this. Yeah, because 0, 4.
And I think that it's.
Okay. So your attention, please. I would like to hear about the focus, directrix, and I want some help graphing from Joanna. Can you help me with these, please?
Vertex is -4 and -2.
Okay, we got the vertex, -4, -2. Good. Now, how are you gonna get the focus though? Any idea? How did you get 4? Nice. So we get that A is equal to 4. So now what do we do with that? How do we get the coordinates? So 0, 4 up here. Now, that would be if the vertex is at the origin, but remember our vertex is at -4 and -2.
This is just is it -4 and 4?
-4 comma. Let's see. We have our vertex. Distance from the vertex to the vertex is 4. The -4 comma. 2. Is that clear that the focus there is -4, 2?
Yeah, could you?
Like Joanna said. A is equal to 4. And do we know that this is opening upwards or is it like a different one?
Upwards was A one.
A is positive and it's x squared. So it's definitely upwards. Remember, the focus is always inside. And by definition, the focus and the vertex are A units apart. So once we have that 4, just count up 1, 2, 3, 4. There it is, the focus. But how about the directrix? Joanna, did you get the directrix? Y is equal to -4. And how did you get y equals -4?
Because like from the vertex to the focus to the.
Remember, the A is equal to 4. So we have to count up to the focus for the directrix. We have to count down 4. So y is equal to negative. Let's see, we're at the vertex is at -2, then go down 4, -6. Are we good with this? Now we've broken through here, so I'm gonna have to extend the graph a little bit, something like this. No, that's not actually important. Okay. John, are you comfortable continuing with the graph? Or should I call another lucky student? You're very kind. I need some help drawing this graph. Sabrina, can you help us out with this, please? Okay.
So, we can't draw the whole thing. Because,
How far?
right on the side. And draw one.
Just a minute. Does that make sense? We'll go 8 to the right from the. Okay, so I think that puts us over here. Is that right?
Yeah.
You said the other one won't fit? Do we agree the other one won't fit? Could you imagine it? Is this enough to draw a pretty good parabola though? Do parabolas have corners? Let's just make it nice and round.
The distance between the vertex. And
So we have that.
Where A is the whole.
We'll continue this way. Thank you. And Joanna, thank you. Any questions about any of this? Do you get it? Yeah, Andrew?
If the, so the.
You got it. You're just working it out. Okay, yeah. That's a processing time. Oh, look, there's another one. Can you take out your pocket parabola and show me the orientation of this one? Think about it, careful.
Oh.
Think about it. There's a negative, but there's also y squared. That's why it is this direction. Is that, wait, I'm sorry, it's this direction. It's this direction, yeah. My bad. Okay. So we'll be calling one person for the vertex. Can you explain to me why it's y squared? This x equals y squared is it's the inverse
Negative
of y.
2 or 2 negative?
No, I
And
know
then
that.
there's another.
But like what makes it so that it's like not this way?
The other.
Oh, I see.
Yeah, a good question.
So, okay, so that is positive. Okay, this is. No, that's.
This is now. Yeah. We're doing
Oh, you want
Okay, so focus would be negative 1.
A, then
Vertex is two.
But then
on
focus,
the original ones.
Well, if it's going this way and focus is inside of parabola, then it's. How would you know? Folks always tell. I doubt it.
because that's. How does he,
Can you tell me the vertex, by the way? I'm sorry. Can you show me the vertex? From your point of view, so X and Y. Are we good that it's 2, -1?
Also, because if you have. The focus is just the vertex plus A. A is -1. Because it's -4. Jesus. Well, I can heard. Words that have off. Because this one, four. This is how it's.
okay, so you're gonna lose it.
Where does it?
Then how do you finish it?
So.
Did you get it? Need some more time? Just 12.5 seconds. Okay, 4 seconds. Okay, so for this one, Sabrina, I feel like you didn't get a lot of chance for that last problem. There wasn't a whole lot of information to share with us. Do you want to continue or should I call someone else? Oh, you're very nice. You sure?
I can take over.
Let's see what Destiny says. Is your name by any chance? Kieran?
Wow.
Wow. How'd you do that, Kieran? Are all these Kieran now?
I got A.
Okay, how'd you get A's -1?
It's because it's 4A just by -4 by 4.
Okay, I like that. Just by looking at it though, right? You know, like, okay.
And then you know that the focus is the absolute value towards where it's going. So
Okay.
then focus is at 1, -1.
Do we agree with that? Okay.
Which means that the directrix is at x equals 3.
Okay. Do
And then,
you want to keep going?
yeah,
Okay.
you know that the first point is at 1, 1. And then like reflected across down to -3 or 1, -3.
Okay.
-1, not 2 negative.
Not too negative.
Sideways,
Yeah, we know it's left, right? Specifically, it's to the left. And that A being -1 leads us in that direction. Okay. Kieran, is this enough? And is this all I need?
Yeah, probably still -1.
Focus is.
And I need to go through that vertex too. That would have been a win-win have that work. That's so close. Are we good?
Focus is.
Yes.
The rest of the way that we draw the parabola, the only other thing is like how we draw the.
Don't get too creative. Just be reasonable and follow that path.
Is the focus
Especially once it gets off the ground and that's a really first.
But like, if you relatively in between the. Okay.
Yeah. Fancy.
So, like for a Y, so like just have a parabola with the A, like the base A be like A's relative to 0 A.
A is 0, or do you mean, wait, let's go back.
In the example, like for the 0 A, then in this case it's be A is 0, so it's replaced the other way.
I want you to think about A as the distance. I can go back to, that's a really good question, thank you. I want to go back to this. A is this distance and this distance.
Yeah.
That's what I want to think of. A is just that distance. Now, if it's negative, there's directional that we have to talk about. So when we did this one here, once we know that A is negative and we have the vertex, and we know it's this way, we can say, oh, the focus is there, direction, one away. So A is a distance. Think about it while we continue. Yes, Rohan?
What's the lattice rectum on the last one?
Oh, good question. What is the lattice rectum here? The length is, show me. Do we see it right there? It's 4.
It's the absolute value of this.
Just like in A, the lattice rectum here was 16. It's actually really nice. Okay. Let's see if we can do this. What are you gonna have to do? What 3 words should come to mind when you're doing this problem?
The square.
Complete the square.
Yeah. You're in the post 0, right? That's what
Did you finish C? Try to do D. So let me stop you. You do that one, also do A. For the next problem. Check in with your neighbor.
No.
Particularly if you're stuck.
Your dad. I had to do one. Oh, you're right. Like it'll be forwards.
You ready? Ready or not? I would like to hear from the one and only Brianna.
I'm a little confused, but I'll go to where I know.
I appreciate that.
Okay, so first thing I did was I completed the square. And I got that y minus 1 squared is equal to 8x.
So what did you add to both sides? You added 1, okay,
And then that cancels out that one on that side.
that's nice,
It's just y minus 1 is equal squared is equal to x.
okay.
And from there, we know that x is 0 and then y is 1. So we know our vertex from there. And then where I got stuck was finding to focus because we plug it into the formula and you get a equals 0, which I might be doing it wrong, but
What formula did you plug it into?
x squared equals 4.
Yes, you're thinking too much there. In order to do this, all we have to do is look at our basic formulas and say, hey, the 4a is just the coefficient of either the y's or the x's there. That's how we get the a. So when we look at this,
It's just 2.
yeah, we say 4a is equal to 8. That's how we know a is equal to 2. And do we know the orientation of this one?
Yes.
It's size.
It's horizontal. Okay, so you want to continue?
Sure, I'll try. And then so if it's 2, then
Oh, I need the focus. Okay, yeah, the focus is
2, 1.
2, 1. Okay,
And that means the directrix would be -2, 1.
I need an equation.
Sorry, x equals -2.
X equals -2. Thank you. Are you okay finishing?
I know the
Lattice recta.
it's,
Yeah,
it's 8.
it's 8. So now what? From the focus, we'll go for which direction? Up and down. Is that right? Up and down?
Yes.
So for up, 1, 2, 3, 4, and then 1, 2, 3, 4. And that's enough to do this?
Yes.
Yeah, perfect. Any questions? Thank you, Rihanna. Andrew, do you have a question?
Yeah, I didn't do this, but do we have to like label our points?
No, as long as it's clear. Thank you. Oh. Let's look at this next one. Oh, and by the way, did anyone just not complete the square for that first one and say, hey, we already have it complete? Do you see that? If you just move that one over there, you can do that. Right, it's just there. And so once you understand the squares, you can play with it that way, just kind of borrow from here, borrow from there. The intuition, yes. Brandon, can you help me with D?
I can't help.
Oh, I like that. The can do, yes.
I added words to those.
Okay. It's perfect. What's wrong with you guys? You're doing great.
And where's it? Factor it in x. X minus 2 squared. And then equals. Then you factor out the 2 times y plus 2. So then the vertex is 2.
Are we good so far, everybody? Wow, doing this on the fly, you're doing great.
Then this
Okay. So let me mark the vertex on here. 2, -2, I think is here. We know the orientation is, everybody can show me the orientation of this. Where is this parabola headed? It's opening upwards, so keep on going.
so focus to
Nice.
direction a 2 comma
I need an equation.
y equals
It doesn't seem like you're doing this on the fly. It seems like you already did it, which is really impressive. Yeah. Okay, and you're gonna help me draw this too?
Right now. It's one of the lattice. Two. That's
Okay.
the one of the ones.
And that's all we need. That's exactly what I'm looking for. Any questions? Brandon, that was great. And you have our amazement and your calm under pressure there. Don't you think? That's tough. That's the hardest time to think. Any questions before we go on? Okay, there is a danger with these problems, like solving this one, we're looking for the equation. There's an assumption that a lot of students make when doing these problems, particularly after the other ones. What do you think the inappropriate assumption would be here? Would it be appropriate to assume that 1, 2 is vertex? Would that be appropriate?
I would assume so.
Yeah.
You would assume so? Is it appropriate to assume that that assumption is okay? Yes, that's fine. Yeah, we're gonna label a vertex. We're not gonna label a point just off the vertex. Would it be appropriate to assume that 2, 1 is a special point? Like what special point? Right, assume might think it's the end of a lattice rectum, correct? Why would you assume that? Do we know the focus?
Yes.
We don't know the focus. So it's an assumption that that's the endpoint of a lattice rectum. So please do not assume that when you're making the equation for this parabola. I'll give you a moment to put it together. But please do not assume that that is the endpoint of a lattice rectum. I don't know if this is not
Bro. It's true. What is it? X.
check in with your neighbors, see what's going on, what they do.
Oh, yeah.
Okay, who can help me out with this? Yes, Sabrina.
This is. Or it's
Vertical.
vertical.
Yeah,
So, it's x minus 1 squared equals, and then, we're trying to find. This is 4a, except there's, times y minus.
okay, before we move on, are we good with this? Is a good starting place? Keep on going.
And then you plug in the 2 sum 1 for x and y, so that's 2 minus 1 squared equals 4a, 1 minus 2. And then you have 1 equals negative 4a. And then it's negative 1 equals 4a. So then it's x minus 1 squared equals negative y minus 2.
Nice. So you didn't want to solve for A?
It's
Does that make sense? We don't need to solve for A. If we do, we'd be dividing by 4 and then plug it back in and multiply by 4. So it makes sense. Thank you for just solving for 4A. So this is just negative 1. So I have x minus 1 squared is equal to negative y minus 2. Do we know the length of the lattice rectum? Can you show me the length of the lattice rectum? We do know it. The length of the lattice rectum here is. I want to see a few people hold it up. It's not 4. Length of the lattice rectum here is. I see a few people. 1. Because 4a is -1, we take the absolute value of 4a, remember, that's the length of the lattice rectangle. 1.
Oh.
So it'd be like over here, wouldn't it? It'd be like in there somewhere. It's definitely not the end of it. At that point we have is not the end of the lattice rectangle. Yes,
Is the lattice rectum the entire like distance between all of them, or is it just like the half between the vertex, or not the vertex, it's the whole, the focus and one side of the graph?
it's from parabola to parabola. Okay. There's not a lot of time left, but I think you have enough. I'm not saying to close up to do these problems, just recognize which one's x squared and which one's y squared. I do want to illustrate for a moment the application of parabolas in the real world. Satellite dishes. The shape of a satellite dish is called a paraboloid, which means no matter which way you look at it, no matter which way you cut it, it is a parabola. Now, why does that shape help? Yeah, what we have is the rays come from a satellite and are basically horizontal to one another. Then they hit the dish, and each one of those rays bounces. Where do they bounce? To the focus, which is where we want the receiver to be. So all of those signals, if you were just to get one signal, that would not be strong. But the signal from that entire field is able to be strengthened into that vertex or the focus right there. So just in terms of how we do this problem, it says 8 feet across and 3 feet deep. So we straighten it up. This point is at 4,3, -4,3. We are looking for the focus. So you need the equation. We do not know the lattice rectangle. We want the equation of that parabola. So you could get the coordinate of the focus, a value. Woo! Hope you liked the conic section, our first conic section. So far, so good. Enjoy your day.
Like that.
See you next time.
Thank you.
Thank you.
Thank you.
Pleasure. My pleasure.
Oh, that's.
Ending the session.
Give me